Alright, I want to show visually, at least somewhat, how what is being considered to be numbers is not actually numbers, it's vectors. So, say for instance, I have two lakes, right? So, there's the contour of this lake, right? And then here's this lake. Okay? Alright, so these are filled with water because they're lakes. In what sense are these the same thing? If you look at them, they look quite different from each other. So we have to do some categorization. We have to do some logical magic to get these two things to be the same thing, to both count as a lake. That magic is what set theory does. Without something like set theory, these are different from each other. They're just fundamentally different from each other. They're not the same. So to say that this is two lakes, we have to be using set theory, right? And once we get there, once we're at two lakes, we have something that we can graph, which means we have a vector, right? If it's graphable, it's a vector. Numbers themselves are not graphable because they're not vectors. Numbers are scalars. You can't actually graph scalars. Once you do, you've artificially turned it into a vector, or you misunderstood what's happening, and you're now dealing with vectors. But I can graph two lakes. Right. Easily, right? We can say here's our lake axis, and here's our origin. Right here we have two lakes. I just graphed it. It's a vector, right? It's a vector from here to here. It has this length and it has this direction. It's a vector, right? Now with things like complex numbers, right? So this is the complex. Probably don't need to make it that big. This is the negative i's. This is the positives. This is the negatives. So say I have like 7. So this is positive 7. It's a vector, not a number, because I'm able to plot it on a graph. Now, what happens if I multiply this by I? Well, then I get over here. You know, what happens if I multiply it by I again? Well, I come over here. And what happens if I multiply by I again? Well, now I come over here, negative 7i. And what happens if I multiply by I again? I come over here. The size never changed. The distance from the origin never changed. The scalar magnitude of this thing never changed. The number component of this never changed. The only thing that changed is the direction. The direction is inherently a vector quantity, not a number quantity. So this is not a different number from this. It's a different vector. These are different vectors. And what multiplication by I is doing, or division by I, or however you want to do it, what it is accomplishing is it is converting us between different planes here, right? We're just going from one vector to another vector to another vector to another vector and back again. That's all we're doing. Our distance from the origin isn't changing. The number isn't changing. It's basically the same as if I take 7 and just keep multiplying it by 1, right? In that case, my vector doesn't change. But what if I multiplied it by negative 1? Now I'm just going to be flipping back and forth between these two. So my vector flips back and forth between 7 and negative 7. But the size of it doesn't change, because all that I'm doing is I'm changing the direction of the vector. That's it. I'm not manipulating the number. The number isn't changing. It's like this 2 lakes, right? Or say we have it in money. This might be an easier example to understand. Say I've got, I have a credit card debt of $2,000. Okay. So to me, that's a negative. To the lending company, that's a positive. That's an asset to them. As long as there's some promise that I'm actually able to pay that back, that's an asset to them. They want that. That's right. They see that as a plus. To me, it's a minus. So it depends on perspective, right? So it's very much like, so we got 2 people. Right? How far away are they? Say they're 10 feet apart, right? Okay. Well, and this is Sam, and this is Yuri. Okay, so is Yuri 10 feet in front of Sam, or is Sam 10 feet in front of Yuri? Yes. They're both true. Right? They're both true. Because vectors don't have objective reality. They have, well, like, you can move your origin point. And because you can move your origin point, you can change what direction is positive and negative and I and negative I and J and negative J and, you know, whatever. You can manipulate these because you can just move your origin point and you can rotate your reference frame. So it's not a number. The 10 is a number. The 10 component of this is a number. Not the 10 feet, the 10. So we're measuring the thing in feet. We have 10 of them. That part is a number. Okay. But once it's 10 feet, now it's a vector. Once it's 10 feet in front of you, now it's absolutely, definitely a vector. It's unambiguously a vector. Right? So, yeah, if you can graph it, and if you can do manipulations on it, like mathematical manipulations, like multiplying or subtracting or dividing or any of these things, it's a vector. And that whole thing where he had, let's see if I can remember this. I'm probably going to fuck this up, but that's okay. So he had something like this, 0, 1, blah, and there's some more shit, right? Okay, so what he's doing here, or no, this was -1. I jumped ahead. Okay, so basically what he's doing here is he's setting up a system where we start with our 0, we start with our reference point, and we subtract off 1, and that's what gives us -1. If you're able to subtract from it, it's a vector. If you're able to do a vector manipulation on it, it has to be a vector in the first place. So this 0 was not a number in the first place. It was a vector in the first place. And when we subtract 1 off of it, that's also not a number. It's a vector. Not a number. It's not is not spelled with an A. Okay. That's not a number. That's a vector, and that's a vector. And they're interacting to generate another vector. That's how we're getting a -1 here. This is not a set theory description of -1. Like, if I completed this whole thing. This is not a set theory description of -1. It is a set theory description, or the number -1. It is a set theory description of the vector -1, because there is no number -1. The one component in -1 is the number. The negative component is the unit. If you have units, like lake, or feet in front of, or something like that, if you have units, it's a vector, not a number. So, like, all of this work on how do how do you describe numbers? How do you define numbers? How do you, whatever. What are numbers? It's been done wrong because it's all about vectors. All of the work on it is actually about vectors, not numbers.